Subnetting allows us to take bits from the host portion of an IP address and give them to the network portion. Although this decreases the number of available hosts for that network and results in a loss of usable IP addresses, it provides several benefits for those who subnet. Chief among these benefits is the ability to break a network address up into separate broadcast domains, thus confining broadcast traffic to each subnet. These subnets are then connected to each other through routers. Let's take a look at subnetting. You can subnet any class of network, but basically the idea behind subnetting is that you sort of rob Peter to pay Paul, or you take bits from the host portion and you can give them to the network portion. You can also supernet, which is going the other way. You can take bits from the network portion and give them to the host portion. And why might you want to do this? Well, a lot of times you don't need to use all of the available hosts on a particular network. And sometimes if you have different floors in a building or different buildings or areas of an organization, you might choose to put each on its own separate subnet, because a separate subnet or a network is a separate broadcast domain. And if you have too many hosts on one subnet or one network, it generates a lot of broadcast traffic, and that degrades the network's performance considerably. However, if you can limit that traffic to a subnet or network, and then connect those subnets and networks via routers, you can contain all of that broadcast traffic onto a particular subnet. So let's take a look at some examples of subnetting. Yo, let's bust up some broadcast domains, people. Yippee-ki-yay and oorah! Here we have a company called Meat and Things, and they're a sandwich shop that specializes in exotic meats. They have 7 locations and 6 computers in each location. The key phrase here is 7 locations, so 7 different geographical locations, 7 sites. That would be 7 subnets. So we need to accommodate that in our subnet bits, and they need 6 computers in each location, so we have to accommodate at least that number of hosts per subnet. And let's look at all the combinations here. We can't use just 1 bit with classful IP version 4 subnetting, because it would either be all off or all on. Let's say we use the 128-bit. And we need to have it so that at least 1 bit is on and 1 bit is off. So the minimum number of bits that we could subnet on would be 2. In this case, we'd have to start here. Notice the formula 2 to the power of 2 minus 2, which would give us 2 subnets. That means that over here, if I'm using 2 bits for subnetting, there's 6 bits left for hosts. So look at the formula. 2 to the power of 2, 2 subnets. 2 to the power of 6, the remaining bits minus 2, gives us 62 hosts. Okay. And then the next valid option would be 3 bits. I could do this. Okay. If I did 3 bits, it would be 2 to the power of 3 minus 2, or 6 subnets. And then the remaining bits would be these 5 for the hosts. So it would be 2 to the power of 5 minus 2, or 30 hosts. Okay. Let's take a look at the next combination. Let's say I decide to use 4 bits for subnetting. Well, in this case, 2 to the power of 4 minus 2, I can get 14 subnets. And that leaves 4 bits remaining for hosts, so 14 hosts. And in this case, this is the first one that really fits. These 2 here were too small. We had enough hosts, but not enough subnets. This middle option here is the first one that will both accommodate the number of subnets we need and the number of hosts we need without wasting too many IP addresses. And finally, these last 2 combinations, if I were to use 5 bits for subnetting, I'd get 30 subnets. And that only leaves me 3 bits for hosts, so I could have 6 hosts. I guess you could argue that we could use this combination, but this would probably be a better combination, because we'll have room to expand IPs in each subnet. If people want to add new devices, a router, a printer, an iPhone, a laptop, something like that. Finally, let's move on to, I have 6 bits here, our last option. That's a valid option anyway. I'm using 6 bits for subnetting. Then if I apply my formula, I get 62 subnets. But that only leaves 2 bits remaining for the hosts. So 2 to the power of 2 minus 2, I can only have 2 hosts per subnet, though I might get 62. Okay. And finally, I can't really go any further. I can't utilize 7 bits. Again, that would kind of break the rules, because the host bits can't be all on or all off. So if this were the last octet, and I were using these 7 bits for the subnet part or the network part, that would only leave me 1 bit left for the host. And that would either be the network address all off or the broadcast address all on. So we can't do that because we wouldn't get any valid IPs. Okay. So looking at the options, I can assess that this is the best combination here. Using 4 bits for the subnets and 4 bits for the hosts. So I'm going to go 0, 0, 0, 1. Now the lowest bit is my block value right here. So 16 is my block. And this, not only will that give me the block, but I can also find the subnet mask. If I add these 4 up, 128 plus 64 plus 32 plus 16, that gives me 240. So let's fill out our chart. The number of subnets possible based on our formula is 14. The number of hosts is 14. The number of bits for both subnetting and host is 4. Again, look at the exponents in our formula. The subnet mask is 255, 255, 255, 240. Why? Because we're using a Class C address, and it's the last octet that we're subnetting. And if you add all these together, the 128, the 64, the 32, and the 16, you get 240. So that's your subnet mask. Now, the block is the lowest bit when you set up your subnetting, or if you want, you could simply subtract 256, or subtract the subnet mask 240 from 256. Again, that would give you 16 either way. And if you want to find the the network and the broadcast, the start and end, network is based on the block. The block is sort of the base multiple. So I could just go for a network address on a Class C network, 192.168.116, 32, 48, 64, 80, and so forth. Just incrementing or going up by 16. Now the broadcast is always going to be 1 less than the next network. So if the next network is 32, the broadcast on the previous network is 31, and so forth. And then finally, the start and end, the valid IPs that you could actually assign, well, that's going to be 1 greater than the network, so I have to add 1, and it's going to be 1 less than the broadcast, so I have to subtract 1, going all the way down. Let's take a look at another example. Shoes R Us is a shoe retailer with 2 warehouses sprawled across the Central Florida area. Each warehouse has 50 computers. How will you subnet this network? Well, there's 2 warehouses, and they need to accommodate 50 computers. So 2 subnets, 50 computers. Of all the possible combinations, this is the only one that can accommodate the number of hosts and subnets. So if we choose this option, then we're using 2 bits to subnet on. In this case, we would turn this bit off and turn this bit on. And here's where our network address would start. Right, so our first network would be 64. The next one, we would turn this bit off and turn this bit on. And that would be 128. And there's our 2 networks there. Okay, so this side of the table can't be all on or all off in the last octet, nor can this side of the table be all on or all off, the host portion. So if I wanted to get to the first valid IP, I couldn't turn all these bits off, because that would be the network. So I'd have to at least turn that bit on. Therefore, the first valid IP address would be 65. Now on the next network, on the 128, again, I couldn't turn all of these bits off. Because if I did that, that would be the network address, 128. So the lowest value I can come up with that meets the rules or conditions that they can't all be off on this side or on this side of my table. Remember, I'm splitting it right here. 2 bits for subnetting, 6 remaining bits for hosts, would be this. And so in that case, that would give me 129. So let's take a look at how this would plug in to our facts and figures and formulas. The number of subnets possible is 2. The number of hosts possible per subnet is 62. And again, we have that, or we know that from our formula. Number of bits for subnetting is 2. Notice the exponent value there. Number of bits for host is 6. Notice the exponent value there. The subnet mask, we're subnetting the last octet or fourth octet, so these 3 octets are for the network portion of the class C address. And then 2 bits in the last portion. If I add the 128 and the 64, I get 192. So there's my subnet mask. And to find the block, I could either look at my lowest bit, I know my block is 64, or if I choose, I could subtract 192 from 256. And again, that would give me 64. This is all we need to figure out the network, the broadcast, and a valid range of start and ending IP addresses. So let's do that. Networks would be based on the block value, 64 and 128. The broadcast would simply be if I went to the next network and subtracted 1. Okay, and I can base that on the block value. And then the valid IPs, the start and end, would be in between the network and the broadcast. So if my network is 64, I add 1, 65 is the first actual IP address I can assign. If 127 is my broadcast, I subtract 1, and 126 is the last valid IP address I can assign. And again, let's check that out in the byte table. Just like we saw, 65, right? This bit turned on, the 64 bit and the 1 bit, is the first valid IP that meets our conditions or rules. Now, let's see the last one. If I turned all these bits on, change all these to 1s here. If I turn all these bits on, okay, then I have the 64 and the 32, the 16, the 8, the 4, the 2, and the 1. That's 127. There's my broadcast address. Now, in order for it to be a valid IP, I can't have all those bits turned on in these last 6 columns here. So I need to at least turn this bit off, which means that the last valid IP I would obtain for network 1, or that subnet, would be 126 and 126. So you can use the formula, you can use the block, you can use the byte table. You can use all 3 or a combination of whichever 2 you like. I would recommend using more than one method to kind of check yourself until you get used to subnetting. And kind of like your multiplication tables, once you do it a few times, it'll kind of stick in the back of your brain and you won't even really have to think about it. Of course, you can also download subnet calculators and things from Google, but you'll probably want to understand how the process works and know what you're doing even before you use a subnet calculator and start punching figures into it. Let's look at another example. Jelly Jeans is a novelty clothing shop specializing in clothing with extreme colors. They have 8 locations with 3 floors having 5 computers on each floor. Each floor represents a distinct area of operation requiring a separate broadcast domain. Here's a clue, requiring a separate broadcast domain. So they have 8 locations, they have 3 floors. There's 5 computers on each floor. Each floor needs to be a separate broadcast domain. So we would need to multiply 3 times 8. This is telling us that we need to subnet it by floor, so at least 24 subnets. And we have to accommodate not only that, but at least 5 computers per subnet. Hence our facts or figures here. So again, if I look at all of my combinations, the one combination that would truly accommodate or fit this particular situation is this one here. If I use 5 bits for subnetting, I can have 30 subnets, which gives me more than enough to meet the subnets. And if I have 3 remaining bits for host, I can accommodate up to 6 hosts per subnet. So again, if I choose this option, then that affects the rest of my choices. So if I'm using 5 bits for subnetting, then 1, 2, 3, 4, 5 columns here are allocated for subnetting. That's what gives me 30 subnets. That leaves me only 3 left for hosts, and that's what gives me my 6 hosts. Notice the lowest bit in the byte table is 8 here, so 8 is my block. Alright, and if I were to add all these up, 128, 64, 32, 16, and 8, that's going to give me my subnet mask, which is 248. Now, it's a Class C address I'm using. I could do Class A or Class B, but I don't need all those hosts. Class C is fine for this situation. It wastes less IPs. So that's why we've used Class C for these examples. Because of that, remember at Class C, the first 3 octets or bytes are the network portion. And what I'm subnetting here is the last octet, the host portion, or what would normally be the host portion. But I'm using 5 bits of that, so instead of 0, it's 248 by adding all these together here. Okay, there's my block. I know my block because it's my lowest bit, or if you choose, you could subtract the subnet mask from 256. Having this information, let's look at the network, the broadcast, and the range. Network's based on the block. Remember, the block is sort of the base multiple. So I would start at 8, and sure, I sacrifice or I lose a few IPs when I subnet. But the idea is not to conserve IPs when you subnet. The idea is to contain traffic in broadcast domains, and possibly for security purposes, and there are other reasons. But conserving IPs is not one of them. So based on the multiple, I would start with 8, 16, 24, 32, and 40, just adding the block to itself. The broadcast, if I go to the next network and subtract 1, that's the broadcast. So here, if I start 192.168.1.8, and I know the next network is 16, if I subtract 1, my broadcast is 15. And so forth all the way down. That's what we did here. So if I know the network, and I know the broadcast, finding the valid range of IPs is easy. So I add 1 to my network, and I get my first valid or actual IP address that I can assign. I subtract 1 from my broadcast, and I get my last actual or valid IP that I can assign. 9, 10, 11, 12, 13, 14, 15. And again, that gives me the 6 hosts. And just in case, you're having maybe some difficulty understanding, let's look at this in the byte table one more time, all right? So if I look at the block value, this is the lowest we can have in terms of the subnet bits being turned on. All of these turned off, the 8 turned on. Remember that I can't turn all these on because that's the broadcast. If I did 8, 4, 2, and 1, in that case, that would actually be 15. That's the broadcast. And again, notice 15 is the broadcast. Okay? And I couldn't turn them all off. That's not a valid IP either. That's just a network address. So this part would be the subnet, and this part would be the network. So the first valid IP that meets my rules or conditions, and remember those rules or conditions are that I can't turn all the bits on or off on the subnet side, and I can't turn all the bits on or off on the host side. So to meet that condition here, in this instance or in this example, if I turn the 1 bit on, then 9 will be my first valid IP. And notice right here, 9 was our first valid IP. And if I turn everything on except the 1, to avoid it being a broadcast, boy, butterfingers today. If I turn everything on except the 1, then notice that's my last valid IP. Right? 8 and 4 and 2 are 14. It's my last valid IP. Look at a few more examples. Candy Cuddles is a distributor of fine chocolates and greeting cards. They currently have stores at 9 different locations with 10 computers and a router at each site. How will you subnet their network? Well, if you count the router having an IP address, you need at least you have to accommodate at least 11 hosts. How many subnets do you need? They have stores at 9 different locations. So 9 distinct sites are subnets and 11 hosts per subnet. And all of our possible combinations, if we're going to use a class C in the 4th octet or the 4th byte, this is the only one that would fit. And we've done this one before. Again, 4 bits and 4 bits, 14 subnets, 14 hosts possible, a subnet mask of 240 by adding all these together. And if we come down here, again, based on the block value, the network would be 16, 32, 48, 64, and 80. Since our block is 16, the broadcast, one less from each preceding network. So if the next network is 32, then the broadcast of this one's 31. And then that makes it easy to find the range. The first valid IP, I'm going to add 1 to the network. And the last valid IP, I'm simply going to subtract 1 from the broadcast. Okay. Next, Dandy Candy is a manufacturer of exotic lollipops and lollipop accessories containing mealworms, crickets, spiders, and other unusual candied edibles. They have 4 locations with 2 floors having 12 computers on each floor. Each floor represents a distinct area of operation, requiring a separate broadcast domain. So again, 4 locations, 2 floors, multiply it, you have 8. You basically require 8 subnets, and you need to accommodate 12 hosts per subnet. Again, that means the middle option is the only one that applies here. It's the only one that can accommodate the required number of subnets and hosts. Notice all of these are the same. 14, 14, 4, 4, a subnet mask of 240 from adding these all together, and a block of 16. And once I figure that out, notice these are all the same. Multiples of 16 are my network address. From the preceding network or the next network, if I subtract 1, that gives me the broadcast of the previous network. And I can figure out the range in between. Silly Saplings is a nursery and shrubbery distribution corporation. They grow plants, flowers, and shrubbery at 10 locations with 10 computers each. They also distribute their saplings at 3 retail outlets with 7 computers each. How will you subnet this network? Well, again, you need 13 subnets at least, and you have to accommodate 10 hosts per subnet. So this appears to be the combination that can, or the combination of host and subnet bits that can fit that situation the best. If that's the case, and I'm using 4 bits, again, off, 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 and 1, we'll turn the 16-bit on. Notice that that affects the number of subnets and hosts, the bits used, the subnet mask, the block. And again, the network, the broadcast, and the range are the same. Last but not least, here's a company called SuperSex. And they have 25 locations with 2 floors having 15 computers on each floor. Each floor represents a distinct area of operation requiring a separate broadcast domain. How can we subnet this network? So I need at least 50 subnets, and I need to accommodate 15 hosts per subnet. I can't do that because here, at least if I were going to do that with a class C in the last octet, the problem is I have to use at least 6 bits to get my 62 subnets. And if I do that, that'll accommodate the 50 subnets, but I can only fit 2 hosts per subnet if I do that on the last octet, and that won't accommodate the required host here, which is 15. So this tells me I need to sort of depart from class C and look at maybe using a class B address. So let's make a mental note. I have to subnet on the 3rd octet, not the 4th, again, just to achieve the required number of hosts. If I did that, and I still allocated 6 bits for subnetting, I'd get my 62 subnets, which would accommodate the 50 that are required. And then there would be 2 bits left in the 3rd octet, and 8 bits left in the last or 4th octet. So that would give me 2 to the power of 10 minus 2, or 1,022 hosts. It's kind of overkill, but this is what would actually fit the situation. And so basically the number of subnets possible would be 62. The number of hosts, 1,022. The bits for subnetting, 6. And since I'm using 2 octets instead of 1, the remaining 2 bits in the 3rd octet and the remaining 8 bits in the 4th octet give me 10 bits for hosts. And my subnet mask would be 255.255 because the first 2 octets, or 16 bits, are completely dedicated to the network. It's class B. But then I'm subnetting. So in this case, in the third octet, I would be using all of these bits here, down to the 4. And my basic block value would be 4 since that's the lowest bit. So instead of the fourth octet, remember this is the third octet, these 6 bits are the subnet portion. And then these 2 bits in the third octet remain for hosts. But in addition to that, there's 8 more bits in the next octet. So I add them together, and that's 2 to the power of 10. Based on that, my network address would simply be based, again, the base multiple or block is 4. So 151, 4, 8, 12, 16, and 20. The broadcast, simply subtract 1 from the next network. Okay, and that would be my broadcast. And then the range would be in between. I add 1 to the network, and I subtract 1 from the broadcast.